Okay, we're moving on to Chapter 9 of ChromeKey, Managing Multi-User Databases. Multi-user, very interesting. We've avoided all the multi-user issues so far in the course. You each have your own database. You're the only one that uses it, other than occasionally I'll poke at for grading. But basically, we don't worry about stepping on each other. But in the real world, most database work, one of the things that makes it useful is the fact that multiple people do hit the same database, the same data items, and the database has to pull that together in a way that nothing gets lost. As we'll see, that gets a little bit involved. Okay, the warning. These slides are modified from Cronky and Auer. I want to give them their due. Chapter 9 specifically due to our emergency online teaching. So, our basic problem. This is the classic multi-user transaction problem, and it deals with having a bank account and moving money around. So let's say Alice writes Bill a check for $100, and we're going to keep the problem simple. We don't get rid of the problem by having multiple banks, but we're going to keep it simple by having one bank, and in fact one computer for the database, and we assume that Alice and Bill have the same bank and Bill deposits the check. So the bank will then move $100 from Alice's account to Bill's account, right? That's what you do when you get a check. Okay? So let's think about this. So Alice has some starting balance. Let's say it's $500, and Bill has a starting balance. Let's say it's $200, and we subtract the check from Alice's balance, and we add the check to Bill's balance, and Alice ends up with a balance of $400. We've taken the $100 out, and Bill ends up with $300. We've added the $100 into Bill's account. Hopefully this makes sense to you. Otherwise, you're not going to understand the rest of this. But it's pretty straightforward, right? So this is the way we expect it to work. What could go wrong? And of course, that's where it gets interesting, is when something does go wrong. So let's trace through this again, but we have one little addition this time, and that is what happens if we have a crash. It could be some other kind of interruption, a network failure. There are a number of things, but the classic example is, what if the computer crashes partway through it? So Alice has her starting balance, Bill has his. We subtract the check out of Alice's account, right? And then we have a crash. And we bring the system back up, and what do we see? Well, we see that Alice's balance is down by $100, but Bill's balance hasn't changed because we haven't handled Bill's addition yet. Now we have a problem, right? The system is out of whack. What to do? What if we just rerun the whole thing? This would be bad because we would subtract another $100 out of Alice's account before we add to Bill's account. Alice would be very unhappy. What if we add the money to Bill's account first and then subtract it from Alice's account? Well, this just moves the problem around by a little bit. This means that when it crashes, Bill will have the $100, Alice will still have the $100, so effectively the bank will be out of $100. The bank doesn't really like that approach. So what do we need to have happen? Either both the add and the subtract should happen, or neither should happen, because if neither happens, we could safely rerun the whole thing. This is the basic idea behind a transaction, is we want to identify a block of work where if we either finish the whole block or we finish none of it, and as a result, it's easy to rerun it or not rerun it, okay? This idea is more formalized as atomic transactions. A transaction, or a logical unit of work, Cronky calls it, I've never heard anyone else call it that, is a series of actions taken against the database that occurs as an atomic unit. So either all the actions in a transaction occur or none of them occur. It's a key concept to get your head around. Here's Cronky's explanation. His is a little different than the classic. I mean, it comes to the same point, but he goes through slightly different steps. So Cronky sets up a scenario where he's got three things that should all happen together. Okay, so what he's got is he's got a customer that orders stuff, and that means what the customer owes changes, and then he's got a salesperson that gets a commission on selling the stuff, and so the commission should change. And then finally we create the order that the person's bought the stuff. Okay, so here on the left we've got the customer, we've got the salesperson, we have the order. This is the before transaction. We're about to do something with this. The customer is about to order a second item. So the customer here on the left has on order 400 baseballs, it's order number 1000. We can see down the order file there's an order number 1000. And this money for the baseballs is part of what the salesman sold, so it's part of why he has the commission that he does. But notice down at the bottom that the order file is full. There's no more disk space, so there's no room to create the new order entry. So what happens? So we start and we add new data to the customer. We assume that fits, and you can see we've added order 8,000 for 250 basketballs. That's highlighted in this dark green, and that costs something. And then you can see we've updated the salesperson to increase his total sales and increase his commission due. So far, so good. But now we go to insert order number 8,000 into the order file, but the disk is full and it can't be done, so it doesn't work. So we've got the customer owing us more money. We've got the salesperson getting more commission, but we don't have the order because we couldn't put it into the system. This is similar. It's 3 steps, but it's similar to what I just ran through where we have a problem, right? So what do we want to do? We want to set this up as an atomic transaction. Same scenario, same before, same after, but in the middle for the actions, we formalized it a little bit. We have this statement, begin transaction, and SQL databases support something very much like this, begin transaction. And everything in the transaction, changing the customer data, changing the salesperson data, and sorting the order file. When we get down to there, we check and see if we have errors. We'll have an error in this case because the order file is full, so we'll have some error that we couldn't write to the order file. So if we have no errors, then we call something called commit transaction that says, hey, I was able to do everything I was supposed to. We're done. So now we know that we don't have a partially completed things. Otherwise, if we do have an error, then we're going to roll it back. We're going to undo our transactions. We're going to put the salesperson back where they was, put the customer back where he was. You'll notice that's the difference between this after and the after we had a minute ago, is the customer and the salesperson are both unchanged because we couldn't create the order. So this is where we're trying to get to. But it's a little involved, and we're going to poke at it a little more first. So concurrent transactions, these refer to, actually I'm going to stop it right here.